Our task was to create a system that can monitor the activity of caged zebra finches, specifically how many times they visit the food perch and the water dish in the cage. Previously, this was done by keeping track of the birds manually with the assistance of the GoPro. This is neither an efficient nor accurate method of tracking the birds, so we came up with a radio frequency identification, also known as RFID system. Our RFID system is able to sense when the birds are at specific points in the cage, in this scenario the food and the water dish. Using the readings we get from the antennas, we're able to keep track of how many times that each bird visits each perch, thus monitoring the activity of the caged zebra finches. Our task is to track caged birds, so we had some distinct parameters. As they are caged, we can assume that there is a limited number of birds in a confined space. Knowing these parameters, we brainstormed options. Further investigating these options led to our three main ideas. Through careful analysis and use of the design matrix, we decided to move forward with an RFID-based system. Then, detailed designs and sketches were made of the system. With these designs and sketches, we moved on to the prototyping phase. There are two parts to our prototype: the RFID system and the Arduino code. We began to make our prototype by fabricating our antenna. To create our desired shape, we first outlined it with screws. We then wrapped the 28 gauge copper wire around the screws, creating a rectangular shape. Once the wire completed 120 loops, we unwound the wire until it had a frequency of 125 kilohertz. This did not work, so we decided to use a pre-made wire and adjust it to fit around the food dish. The second part of our prototype is our code. The code is meant to detect when a bird wearing an RFID tag lands on a perch outfitted with an antenna. Once the tag is detected, the code will determine and record the UID number of the RFID tag. The photon board will then log the detection. This is an example setup of the prototype. When a bird wearing an RFID tag lands on the food perch, its UID will be logged and sent to the console, as shown in this video. To test our final product, we connected the antenna to the RFID reader, which is connected to the Arduino. By moving a sample RFID tag over the antenna, we could determine whether the final product succeeded in the task given to us. The results of the test showed that the final product did, in fact, fulfill the task.